Hi, my name is Martin Griffiths, a co-author of BeamBuddy. So welcome to the first BeamBuddy tutorial. This tutorial will take you through the simple but powerful stages in designing a wooden roof beam and ensuring it meets the recommended design parameters defined by the NDS and IBC. So let's get started. Design a roof beam with a span of 13 foot 6 inches, made of Doug fir, larch, and as far as the load's concerned, we're going to assume we're going to be using plywood sheathing to prevent lateral buckling, and we're going to use gypsum wallboard as the ceiling material. So the goal of this exercise will be to find the minimum beam size to safely carry this load. Here we see the opening screen, a navigation bar along the top, a files button to the left, which takes us to a screen for managing saved designs. No surprises here, currently empty since no designs have been saved. We will be turning here later in the tutorial. To the right, a button that brings up a built-in tutorial. This only takes a few minutes to digest, lots of pictures and a few words, and will answer most of your questions about the application. To exit the tutorial, you just double-click the screen at any time. Before we start this design, just a few words about setting up the loading conditions. Tapping the beam will bring up a palette of loading scenarios, from the very simple to the more complex. We'll be adding to this palette in future updates. To give you a couple of examples, here we have a concentrated load at some offset along the beam, and for a more complex example, here we have a uniformly distributed load along a beam with an overhang and a load at the end of the overhang. Notice I only need to touch the beam to bring up the palette. I then have the option of selecting an alternative condition or exit without selection by swiping to the right and returning from where I left off. So let's get back to our design problem. This exercise defines a simple loading condition. So we touch the beam and select Figure 1, a uniformly distributed load spanning the entire length of the beam. So we dial in the span length, which we said was 13 foot 6 inches in our original specification, and the distributed weight we will estimate around 50 pounds per linear foot. We are in fact working on an estimator as a companion product or possibly a built-in feature, so this could be estimated more accurately from input. Now that we're done with the loading requirements, we can start with the design phase, which has 3 stages: material selection, beam sizing, and adjustments. Notice the left and center graphs show the required section modulus and shear area relative to the minimum allowable values defined by the red lines. The right bar graph shows the maximum beam deflection, and references are also using the grayscales to the code deflection limits on the right. Another neat feature, by single tapping the section modulus or shear graphs, the graphs will switch to show the required bending and shear stress ratios. In this case, the red bars defines the maximum allowable. So back to stage 1, material selection. In our case, we're going to select Doug fir larch number 1. We do this by changing the picker to Doug fir larch number 1. Looking at the section modulus, we see it's way above the minimum requirement. So currently we have an over-engineered solution. Correct sizing of the beam will solve this. The size picker shows nominal values for sawn lumber, but dressed or final values with engineered woods. The size picker also shows only standard dimensions. This makes selection easier and faster. So let's reduce the beam size to a value that brings the section modulus down to the red line, while also noting that the shear stays green. We'll deal with deflection in a while. Now let's see what effect some of the allowed adjustment factors will have on the section modulus. This could affect our final beam size. We'll select a load duration factor of 1.25 for a roof design and ensure the repetitive member factor is applied. And notice only the section modulus is affected. So by applying these two adjustments, we have increased our safety margin. Maybe we can reduce the beam size further and still be within code. So we reduce the beam depth to 6 inches. The section modulus looks okay, but we have a deflection issue. So for this design, I'm going to stick to the original depth. So now that we've completed our design, let's get a sneak preview of the report. We do this by just double tapping the screen. This can be done at any time during the design process. A cursory glance of the report shows everything to be as expected. Note that the size factor has been applied automatically by BeamBuddy. The output summary reflects what we have seen graphically. To complete the analysis phase, the user can also review the moment, deflection and shear diagrams. For each graph, the values at any point along the beam are clearly displayed when touching and dragging the cursor. By touching the bounded legend to the left of each graph, the third graph will now be displayed. Once satisfied with the design, it can be saved for emailing and later recall. Once we have actually entered our data, we just press done and it's saved to the filing system.